Scientific notation. It must be very complicated because it's a special notation for science, okay? It's not hard, guys, okay? I'm going to show you right now. It's really not hard at all. We just need to go and walk through it step by step. The big picture is, okay, for scientific notation, the big picture is when you're talking about very large numbers or very, very small numbers, it gets very inconvenient to write the number down just as you would think. Like, let's say you're talking about taking a trip to the grocery store. That's pretty simple. If the grocery store is, 2 miles away or 3 kilometers away or whatever, you tell somebody it's 3 kilometers, no problem, to the grocery store, okay? Now, let's say we're going to go to the planet Neptune, okay? That's very far away. I haven't looked it up, but I know that in miles, it's millions of miles away, okay? And if I'm going to write that number down every time, I'm just picking this out of thin air. I'm sure this is completely wrong, but let's just say it's 2,374,900.5 miles or something like that. Who wants to write that down every time? Okay, nobody does. Okay, so when you're dealing with big numbers, it's very cumbersome to write all those decimals out. And also when you're talking about very small things, like you're talking about the width of a human hair, or let's say you're an atomic scientist and you're looking at the diameter of an atom, or the shape of a molecule. Well, those things are incredibly tiny, okay? Very, very tiny. Millions of times smaller than anything that we're dealing with on a daily basis. So you don't want to write 0.000000005 meters. You don't want to write that down because you're going to be writing these, your homework down in your papers or whatever. It's going to get maddening trying to do that. So there's an accepted standard for writing very big numbers and very, very small numbers. It's very simple to understand, and it's just called scientific notation. That's all it means, okay? It's something you'll see in every science class you take, okay? So before we actually get to the scientific notation, let me give you one little primer I think is going to make it easy for you, okay? So let's do that now. Okay, now let's take a trip down memory lane here. Here's the number 10, okay? You'll see where I'm going with this in just a second. Here's the number 10. Because again, I'm not going to assume you know anything at all about this stuff, so we're going to start from the very beginning. If I'm going to tell you, okay, 2 times the number 10 times the number 10. This is not a variable x, this is just multiplication. 2 times 10, well, we all know that's equal to 20, right? Okay. Now, just hang on to that in the back of your head. It's not something that we're really going to need at the moment, but I'm just going to write it down just to show you that. Now, let's say you have 10 squared. Do you know what 10 squared is equal to? Well, from your algebra, you know that a square is when you multiply something by itself. So 10 squared is 10 times 10, which you should know is 100. So 10 squared is equal to 100. Okay, so what I'm going to do under here is I'm just going to say this is equal to 100. You all know this, okay? Now let's go up and say 10 cubed. Okay, what is 10 cubed? This would be 10 times 10 times 10, because that's what 10 cubed is. So 10 times 10 is 100. 100 times 10 is 1,000. So 10 cubed is 1,000, okay? Let's keep going. 10 to the 4th power, okay? Well, that would be 10 times 10 times 10 times another 10. This is going to be 10,000. Okay, let's do one more. 10 to the 5th power. What is that? Well, that's 10 times 10 times 10 times 10 times 10. If you put that in a calculator, you'll keep going. So you've got 100, 1,000, 10,000. You multiply by 10 one more time, and you're going to get 100,000. You see the pattern here? Every time I add another increment the exponent here, I'm multiplying what I had before times 10. So everything here is getting 10 times bigger than before. Okay, this will all make sense with scientific notation here in just a little bit. So going this direction, we get bigger and bigger, right? That's what this is saying. 10 squared, 10 cubed, 10 to the 4th, 10 to the 5th. This is all going bigger and bigger and bigger numbers, okay? Now let's go the other direction, going like this. What is 10 to the minus 1? Because here's, 10 squared. Actually, this is 10 to, effectively, this is 10 to the 1st power right here, okay? 10 to the 1st power, I could write like that is equal to 10, okay? So what would be 10 to the minus 1? Well, you should remember back from your algebra that anytime you have a negative exponent, that's just 1 over, you take what you had and make it a positive exponent. So it's 1 over 10 to the 1st power, okay? So it's 1 over 10, which is another way of saying 1 over 10 is 0.1.